Welcome to solverfy.
So today the problem that we are solving is a two-part problem. The first part, a bowl contains 10 red balls and 10 blue balls. A woman selects balls at random without looking at them. You can see that I've done a mini sketch here of sort of the background of this problem. And so our question for the first part is, how many balls must she select to be sure of having at least 3 balls of the same color? We'll be solving this using the pigeonhole principle. And so in this case, the pigeons are our 10 red and 10 blue balls, and our pigeonholes will be the colors. So we have a red pigeonhole and a blue pigeonhole. And so we need to consider, how many balls does she need to pull out in order to know for sure that she has 3 of the same color? So consider what happens if she pulls out 3 balls. There is a chance, not a 100% chance, but there is a chance that she pulls out all of one color, let's say red. But that isn't particularly likely. Maybe she pulls out 2 red and 1 blue, right? Or alternatively, she could pull out 1 red and 2 blue. But we don't know for sure. But notice here, so if she's pulled out 3 of all the same color, then we are satisfied. But our only other options, if she's pulled out 3, are 2 in one and 1 in the other. And it's just flipped between the two. So now think about what happens if she's pulled out 4. So if she's pulled out 4, maybe it's all 4 red, and then again, we're satisfied. Maybe it's 3 red, 1 blue. And again, we're satisfied because we would have the 3 red. Maybe it's 2 red and 2 blue. Maybe it's 1 red and 3 blue. And again, we're satisfied. So notice in this case, the only case in which we are not satisfied is when she pulls out 4 balls and they land as 2 and 2, an even split. And this is because of the pigeonhole principle. So right now we have our 4 pigeons spread across the 2 pigeonholes, and there's 2 in each hole. But what we're asking about is when there's 3 in each hole. So now consider what happens if we draw 5 balls, which are equivalent to pigeons. Now, in our unlikely case, maybe all 5 are in 1, 2, 3, 4, 5. Yes, sorry. Maybe all 5 are red. Maybe all 5 are blue. In that case, we are satisfied because we have at least 3. We have over 3. We have 5. Maybe it is, 4 and 1. Either way, we're satisfied, whether it's red or blue. Maybe it's 3 and 2. Either way. And notice, that's the lowest that it can go. That there will be 3 in one pigeonhole, or one color, and 2 in the other. Maybe, maybe it's 3 in the red, 2 in the blue, maybe it's 2 red, 3 blue. But because of the pigeonhole principle, once we've drawn 2 and 2, we know that our last ball here, it has to go, either there or there, but either way, we'll be satisfied. And since we have to draw 5, we're guaranteed to reach either this case where we have 2 and 2, or if we were to not reach that case, then we would have more stacked within 1, in which case we would also be satisfied. And so the answer to this using the pigeonhole principle is that she will have to draw 5 balls. Now, for part 2, our question that we are seeking to solve is, how many balls must she select to be sure of having at least 3 blue balls? So notice how this is different from our first part. In the first part, we just wanted to know, regardless of the color, when she would have 3 balls, which are the same. But now we want a specific color. Now we need it to be blue. This is our goal, is blue. But now consider, it's unlikely, of course, but there is the chance that she'll draw all 10 of the red first. Not quite sure if that's 10, but you understand. So there is a chance that she'll draw all 10 here. All 10 will be in the red, and she won't have drawn any blue. So we know that we need to draw at least 10. And so then on top of that, in order to guarantee that we have at least 3 blues, we'll draw 3 blues. And so we have 10 plus 3, and our answer here is 13. Oh, sorry about that. 10 plus 3 equals 13. So the answer is that she needs to draw 13 balls in order to satisfy this, because there is the chance that all 10 go into the red pigeonhole, and then we need 3 in the blue pigeonhole. Of course, it will probably be less because it is extremely unlikely that she would draw all 10 of the red, but this is the way to guarantee it.